This is class 15 of my arithmetic course. Today we're going to be multiplying and dividing mixed numbers. Now, the easiest way to do this is to first change the mixed numbers into improper fractions. So we learned how to do that in the last class. In the last class we added and subtracted mixed numbers, and today we're multiplying and dividing. And again, we learned how to change a mixed number to an improper fraction. So let's go ahead and change this first fraction to this first mixed number to an improper fraction, and change the other one to an improper fraction. And now it's going to be pretty easy to calculate the product. Remember, when you multiply fractions, you just multiply the numerators straight across, and you multiply the denominator straight across. We learned that in class, I believe it was class 13. So 27 times 10 and 7 times 9. Now the reason that I left those products factored, instead of writing 270 over 63, because 27 times 10 is 270, and 7 times 9 is 63. The reason that I left them in the factored form is because those numbers are really big. So we're going to go ahead and leave them in that form, and then we're going to continue to factor. And we did this before, so you may recall this. If you don't, that's okay. This is review. So we're going to keep the 7 because that's prime. And we're going to factor 27 to 9 times 3. And let's see, what else can we do? I'm just going to leave the 10. I don't think we can do anything with that. So we just left the bottom as 7 times 9, but 27 we changed to 9 times 3. And the reason we did that is because you can see, let me move this G, this 9 cancels out, and then you can recombine 3 times 10. Sorry, my computer's going a little slow. 3 times 10 is 30. And 7 times, this would just be considered 1, so it's just 7. Alright, so we have 30 over 7. Now at that point, you might be tempted to just leave that answer, but we can't leave it. We can't leave the expression as 30 over 7. And do you remember why? Well, it's an improper fraction. We don't like leaving our answers as improper fractions. And the reason we don't want to leave it as an improper fraction is because it's just it's not easy to understand as 37ths. It's much easier to understand it as a mixed number. So remember, to convert from an improper fraction to a mixed number, you see how many times 7 goes into 30. It's not going to go evenly, but it is going to go in. And I know my multiplication fact, so I know it goes 4 times, because 4 times 7 is 28. 30 minus 28 is 2. And rewrite the denominator. Now, if this stuff doesn't seem familiar to you, that might be because you didn't do the homework. If you didn't do the homework for class 14, you shouldn't be listening to this video. You shouldn't be watching this video or listening to it. You should go back and do the homework from class 14. Remember what I said, you can't go forward in this course unless you do the homework. Now, if this stuff is just a little bit unfamiliar, then that's just because you did it a couple days ago, but we're reviewing it now. All right, so next problem, same thing. We're going to convert 5 2/5 to an improper fraction. And in case you forgot how to do that, by the way, I didn't explain it on the previous problem, but you take 5 and multiply it by 5, then you add it to 2 to get 27, and you keep the denominator. So 5 times 5 is 25, plus 2 is 27, and keep your denominator. Then you take 4 and 1 6, you multiply 4 times 6 to get 24, and then you add 1 to get 25. And you keep the denominator. So that's what we learned in the previous class. So we first convert the mixed numbers to improper fractions. Then we multiply the improper fractions. Now, why did we do that? Because it just makes it easier. Remember in the last class I mentioned that when you're doing calculations, improper fractions are actually easier to use than mixed numbers. So you might be thinking, well, why are we using mixed numbers? Well, again, it's a lot easier to understand 5 2/5 of a candy bar than 27/5 of a candy bar. So anyway, now we can multiply, but these are really big numbers. 27 times 25, I don't know what that is. I don't want to do that. I mean, you could do it if you wanted to. Remember 27 times 25. But I don't want to do that. I want to do it an easier way. So we're going to leave it in factored form. Again, we're just leaving it in factored form because these are big numbers. If we weren't dealing with big numbers, then we could just multiply straight across, I guess. 5 times 6. And and I have a factor of 5 in the bottom, and I know there's a factor of 5 in 25 because I know my multiplication facts. So I'm going to factor. I also know that there's 3 times 2 is 6, and 3 times 9 is 27, so there's a common factor of 3. So I'm going to factor 27 to 3 times 9, and I'm going to factor 25 to 5 times 5. And I'm going to factor 6 to 3 times 2. And again, I know this because I know my multiplication facts. All right? If you're slow, if you don't know where I came up with these numbers, then that means you don't know your multiplication facts at all. If you're a little slow with this, that means you went over your multiplication facts, but you didn't actually memorize them. You got to put the multiplication facts in your long-term memory. And if you didn't do that, go and do it now. Don't do this stuff anymore if you don't know your multiplication facts. You got to go back, learn those multiplication facts. So the reason that I factored in that particular way is because I know there's a 3 on top and there's a 3 on the bottom, so I can cancel those out. There's a 5 on top and the 5 on the bottom. I can cancel those out. So you're left with 9 times 5, which is 45. And I know that because I know my multiplication facts. And 2, we just leave the 2. So 45 over 2. Okay, so 45 over 2, we can't leave the answer like that because the numerator is bigger than the denominator, which means we have a, what is it called? An improper fraction. So we're going to convert it to something that makes more sense. So how many times does 2 go into 45? It goes in, 2 times 20 is 40. This is not one of our multiplication facts, but 2 times 20 is 40. Remember when we learned when you're multiplying a multiple of 10 by some number, you just multiply 2 times 2 and then add a 0, so 2 times 20 is 40. We didn't talk about that a lot, but we talked about it a little bit. To confirm that, just set up the algorithm. 2 times 0 is 0, 2 times 2 is 4. So 2 times 20 is 40. So we need I think 2 more 2s, so 2 times 22 is 44. You can probably do that in your head, but if you want to write it down, that's what it'll look like. So 2 times 22 is 44. So 2 goes into 45 22 times. And 45 minus 44 is 1. That's the remainder, and you just rewrite the denominator. So 5 2/5 times 4 1/6 is equal to 22 1/2. All right, so we're doing a lot of things here. We are, and again, multiplying mixed numbers. It's not exactly a walk in the park. This is not exactly something fun to do. Mathematicians, they usually don't do it this way. They multiply improper fractions. It just makes it easier. But in this class, in arithmetic, in kindergarten all the way through 5th grade, wherever you lie in that spectrum there, you're going to have to know mixed numbers. That's just part of the arithmetic curriculum. So there's a lot going on when you multiply mixed numbers because it requires more calculation. And again, you might be wondering, well, why are we doing this if it's not the easiest way to do it? Well, this is just traditionally part of the arithmetic curriculum, and you are going to need to know mixed numbers for some applications in upper math. So what do you do first? You convert to improper fractions. You multiply 3 times 2 and then add it to 1. And then you keep the denominator. You multiply 2 times 4 and add that to 1, and then keep the denominator. And then once you get to improper fractions, you just multiply straight across. And you keep, and if the numbers are big, you just keep the expression in factored form so you can cancel out. So why don't you try number 3, and when you come back, we'll do it together. All right, we're back. So convert 1 1/3 to an improper fraction, and 2 1/4 to an improper fraction. All right. Now in this case, this isn't too bad, but let's go ahead and keep it in factored form. And you can obviously see that the 4's are going to cancel out. But there's also something else. Before we cancel out the 4, let's go ahead and factor the 9 also. So we have 4 times 3 times 3, 3 times 4. So we factored 9. 9 became 3 times 3. So 4's cancel out, and there's only one 3 in the bottom. So only one 3 in the top can cancel out. So you're left with 3 over 1. Remember, if all of the factors cancel out in the top or the bottom, you just replace them with 1, because 1 is always a factor of every number. So 3 over 1 is equal to 3, and that's our final answer. Why don't you try number 4? And if you didn't get number 3 right, that's fine. Just figure out what you did wrong, and we'll have plenty of practice. So if you did get it right, pat yourself on the back, because this class is going to be pretty easy. And if you didn't get it right, it's still going to be easy, because we're going to do all kinds of practice problems. Number 4, see what you can do with number 4, and when you come back, we'll do it together. All right, we're back. 1 3/5 becomes 8/5. 1 3/4 becomes 7/4. Now, if you're having trouble converting these to improper fractions, just go back to class, to whatever the class was before this, class 14. That's where we learned how to do that. I don't want to keep going over the same thing over and over again, because I don't want to bore the students that have actually remember this. So, and again, if you don't remember this, it's probably because you didn't do the homework. So go back and do the homework. So now, let's see here. Again, we're going to go ahead and again, we could multiply straight across, and we could get 56 over 20. And then we could convert that. But the way we've been doing it, the easiest way, is just to keep it as 8 times 7 and 5 times 4. Then I have a 4 in the denominator, and I know that 8 has a factor of 4 because I know my multiplication facts. So I change 8 to 2 times 4. And then the 4's cancel out, and I'm left with 14 over 5. Now, I can't leave my answer as 14 over 5. If you left your answer as 14 over 5, you would get a point taken off. We have to convert. This doesn't mean a lot in the real world. If you go up to your friend and say, I want 14/5 of your candy bar, he's going to look at you weirdly. If you go to your friend and say, give me well, actually, you know what? He's really going to look at you weirdly, because 14/5 of your candy bar, that would be more than one whole candy bar. I'm trying to think of an example. But, here's an example. Let's say that your mom's making cookies, and you say, Mom, give me 14/5. Give me 14/5 of the cookies. Again, she's going to think that something really strange is going on. But if you see how many times 5 goes into 14, and it goes 2 times, 5 times 2 is 10, 14 minus 10 is 4, rewrite the denominator. If you say, Mom, give me 2 4/5 of a cookie, she might still look at you weird, but she's going to say, well, I think I understand what you're saying. You want 2 full cookies and then almost all of a third cookie. So saying, Mom, give me 2 4/5 of a cookie, or 2 4/5 cookies, is a lot better than saying, give me 14/5 of those cookies. And again, why do we, it seems like we're going backwards because we take mixed numbers and we change to improper fractions, then we take improper fractions and go back to mixed numbers. So it seems like we're going forward and then backwards, but it just makes it easy for us to find the product. 1 3/5 times 1 3/4, that would be really hard to multiply. You'd have to multiply these two numbers and these two numbers and these two numbers and these two numbers and then add them all up, and it would be very difficult. So it's much easier. And what I just showed you, you're not going to learn that until the course after the next one, which is beginning algebra, also called Algebra 1. All right, so number 5, find the product of 2 5/8 and 2 1/6. What does product mean? Difference means subtraction. Sum means addition. Quotient means division. And product means multiplication. Try number 5. And does it matter? Does it matter if we set it up like this? Or like this? Does it make a difference? No, it does not, because of the commutative rule of multiplication. So go ahead and try number 5, and when you come back, we'll do it together. All right, we're back. Change those numbers to improper fractions. Multiply straight across. Keep it in factored form because these numbers are pretty big. And even if they weren't big, it would probably be the easiest way is to keep them in factored form. All right, so let's see here. 13 is prime. That's not going to do us much good. 21 we can factor to 3 times 7. And 8 is just factors of 2, so that's not going to help us. But 6 can factor to 2 times 3. And we have a 3 here and a 3 here. Then we can just recombine, it looks like. So 7 times 13. We don't know that, but you can just take that off to the side. 7 times 3 is 21, carry the 2. 7 times 1 is 7, plus 2 is 9. So 7 times 13 is 91. Because you're recombining the 7 and the 13 by multiplying those and getting 91. And then 8 times 2, of course, is 16. So if you got that far, that's great, but remember, we can't leave the answer as an improper fraction. Now, this one is kind of, these numbers are kind of big here. So we have to see how many times is 16 going to 91. But that's just a division problem. How many times is 16 going to 91? So the only way to do this really is 16 doesn't go into 9, and 16 does go into 91, so that algorithm doesn't really help us. The only way to do this is just multiply 16 by a bunch of numbers. I'm sorry that I gave you such a hard one here. 16 times 5, let's try that one. I think that's going to be it. 5 times 6 is 30, carry the 3. 5 times 1 is 5, plus 3 is 80. So 80, and I don't think any more 16s go in. So that was 5 times. 5 times 16 is 80. And then 91 minus 80 is 11. And then just keep the denominator. So that was a hard one. All right. Why don't you go ahead and try number 6, and when you come back, we'll do it together. All right, we're back. Convert to improper fractions. 3 times 12 is 36, plus 1 is 37. Now, 3 times 12 is not one of your multiplication facts, so I'm sorry I gave you that one. But it's no big deal. So now we're going to write it in factored form because I certainly don't want to do 12 times 37. That would take forever. And we can already see that 12s cancel out and you're left with 37 over 5. So this one wasn't too bad. But again, we can't leave it as 37 over 5. How many times does 5 go into 37? It goes in 7 times. 5 times 7 is 35. And then 37 minus 35 is 2. And rewrite your denominator. So if you're getting these right, then pat yourself on the back. If you're not getting these right, then don't worry because we're going to do a lot more. All right, so number 7. Go ahead and try number 7, and when you come back, we'll do it together. All right, we're back. 3 1/7 becomes 22 over 7. 2 1/8 becomes 17 over 8. Multiply. 22 times 17 over 7 times 8. You just multiply straight across. Keep it in factored form. 22 is 2 times 11. Remember, that's one of our multiplication facts. 8 is 2 times 4. And we have a factor of 2 that's common, so cancel those out. Then we have to recombine. Uh-oh. 11 times 17. I'm sorry I gave you another hard one there. It's hard to design these problems so that every single one is easy for you, but you know how to do 11 times 17. 11 times 17, because we did that back in class 6 or 7, whatever that was. 7 times 1 is 7. 7 times 1 is 7. Put your placeholder. So 7 times 1 is 7. 7 times 1 is 7. Put your placeholder. 1 times 1 is 1. And 1 times 1 is 1. Again, if you don't remember this, just go back to class 4 or 5, whatever that was, and the class on multiplying multi-digit numbers. Okay, so now we multiplied 7 times. We got those numbers. Now we add these two numbers. 77 plus 110 is 187. So wow, that was a big number. 11 times 17 is 187. 7 times 4 in the bottom is 28. Sheesh. This one's big. So now we have to divide 187 by 28. How many times is 28 going to 187? That's division. How many times is 28 going to 187? That's division. How many times is 28 going to 18? Well, first of all, how many times is 28 going to 1? Doesn't go at all. How many times is 28 going to 18? Doesn't go at all. So we have to see how many times 28 goes into 187. The only way to do that, so the long division algorithm, again, isn't going to really help us. The only way to do that is just to take 28 and start multiplying by a bunch of different numbers. Let's try 5. And we want to get close to 187. 5 times 8 is 40. 5 times 2 is 20, plus 4 is 24. Wow, that was too big. Wait, I did that wrong. That should be 14. 5 times 8 is 40. 5 times 2 is 10, plus 4 is 14. So we can probably go one more time. Whoops. 28 times 6. Let's try 28 times 6. 6 times 8 is 48. Carry the 4. 6 times 2 is 12, plus 4 is 16. 168. I think that's probably going to be the most we can go in. 168. So 28 goes into 187 6 times. Whoops, I should have kept that number. That's 120 plus 168. 6 times 28 is 168. 120 plus 48. Yeah, 168. So now 187 minus 168 is 19. The remainder is 19. And just keep your denominator. The numbers on that one were really big. So if you did that one correctly, you should get a medal for that one. Let me just check those numbers. 120 plus 48 is 168 plus 19, 178, 188, 187. That's right. All right, so number 8, what is 3 3/4 times 2 3/20? All right, what is 3 3/4 times 2 3/20? So, and I just want to say, if you're having trouble with this stuff, most likely it's because you didn't memorize your multiplication facts. If you didn't memorize your multiplication facts, that's not my fault. I can't do anything about that. I can't force you to memorize your multiplication facts. That's up to you. So if you're having trouble, just go back and memorize your multiplication facts. There's another reason you might be having trouble, and that's because you didn't do the homework. If you didn't do your homework, again, that's not my fault. That's your fault. I can't make you do the homework. And if you're not having any problems if you're not having issues with any of those things, multiplication facts and homework, then don't worry. Just keep trying. Just keep trying practice problems, and you'll do fine. It just takes a little practice to get this stuff down. So what is 3 3/4 times 2 3/20? Remember, times just means multiplication. So why don't you try number 8, and when you come back, we'll do it together. All right, we're back. 3 3/4 times 2 3/20. I'm just going to do this without talking so I can go faster. All right, multiply straight across. All right, so we don't really see anything so far. No common factors there. Whoops, I lost a 3. Where did that 3 come from? I have no idea where that 3 just came from. Oh, there we go. All right, sorry about that. So now let's factor 15 to 5 times 3. And again, I'm not multiplying, because if I multiply, that'll be a lot of work that we just don't have to do. And then factor 20 to 4 times 5. And now we can see that we have 5's common to the top and the bottom. We cancel those out. And then 3 times 43, you can do that on paper if you want, but that would just be 126. And then 4 times 4 is 16. Sheesh, we keep getting pretty big numbers here. I'm sorry that I keep giving you big numbers. Wait a second, that should be a 9. I'm sorry, 129. 129 over 16. So now again, how many times is 16? We can't leave it as an improper fraction. So we have to see how many times 16 goes into 129. Let's see, if we try 7 times, that would be 70 plus 42. I think it's going to be, let's try 8 times. 8 times would be 80 plus 48 is 100. I think it goes 8 times. So it goes in 8 times. 8 times 16 is 128. 129 minus 128 is 1. And then you rewrite your denominator. Yep, I'm pretty sure that's correct. So that was a hard one. We've been getting a lot of hard problems here. So if you're doing these correctly, then you're doing good. Now, if you're thinking this is a lot of work, well, yeah, this is quite a bit of work. But, mixed numbers is just something that you're going to have to learn. But again, the good news is when you get into upper math, you don't really use mixed numbers much. So you don't have to worry about it. So now we're going to do something that's easier. We're going to multiply a mixed number by a regular fraction. And there's nothing different about this. It's just a different variation of these types of problems. So no tricks here. You already have a fraction here, so you're just going to convert the mixed number to a fraction, just like you did up here. You converted both these mixed numbers into fractions. You took away the whole number and you put it in with the fraction. So 1 and 1/3, that equals 4/3, and you just keep the 1/4. Very easy. All right. And so you can see that it's just going to be 4 times 1 is 4, and 3 times 4 is 12, and you can just divide both sides by 4 to get 1/3. But again, that's kind of going backwards. I mean, why would you do that when you can just write 4 times 1 over 3 times 4 and then just cancel out the 4 to get 1/3? All right, so now number 10. Again, we have the same situation. We have a fraction and we have a mixed number, which is a whole number and a fraction. So we just keep the fraction. We change the mixed number to an improper fraction. And we have 2 times 5 over 2 times 5. Maybe I should write that in the same order. Not that it really matters based on the commutative rule of multiplication. So as you can see, actually everything is going to cancel out. And you're thinking, well, if everything cancels out, then you're left with nothing, so that would be 0. Well, no, you're not going to be left with 0. You're going to be left with 1, because 1 is always a factor of all these numbers. So 1 over 1 is just going to be 1. So the final answer is just 1. I know you haven't seen that yet, but now you have seen it. All right. Let's see here. Number 11. Okay, so keep the fraction, change the mixed number to an improper fraction, and just multiply straight across. So why don't you try number 11, and when you come back, we'll do it together. All right, we're back. Rewrite the 1/3, change 1 and 1/3 to 4/3. And 4 times 1 is 4, and 3 times 3 is 9. And that's not an improper fraction. I think that's the first fraction that we've got that's not improper. So we can just leave it as 4/9. All right. Now, same thing for number 12. Try number 12, and when you're done, we'll come back and do it together. All right, we're back. 1 7/8 is 15 over 8. And so you have 15 times 4 over 8 times 15. And you can obviously see that the 15s are going to cancel out. But if we factor the 8 to 2 times 4, you can see that a 4 is going to cancel out also. So the 4s cancel out and the 15s cancel out. And in the top, there's nothing left. So again, when you consider the idea of nothing, you think it's 0, but this is a factor. We're factoring, so it'll be 1 over 2. All right, try number 13, and when you come back, we'll do it together. All right, we're back. Change 2 1/5 to 11/5. Keep the other fraction. And now I'm going to show you something that might blow your mind. But you don't have to write it as the next step. You can just say, well, there's a 5 on the top and the 5 on the bottom, and you can just change it to 1. So you can divide both these 5s by 5 and get 1, but I'm not going to do that. 1 times 11 is 11, 1 times 22 is 22, so the answer is going to be 11 over 22. But I'm going to just keep doing it the same way I'm doing it, because I think that's easier to understand, rather than doing cross multiplication. Or excuse me, cross-canceling. 11 times 5 or 5 times 22. So we could cancel out the 5s, but I'm going to go ahead and factor the 22 also. 22 is 11 times 2. I know that because of my multiplication facts. So cancel out the 5s and cancel out the 11s. You're left with, again, 1 over 2. That's just a coincidence that we got the same answer as the previous problem. All right, so if you did those right, you're doing good. Now we're going to try number 14. Now 14 is different because we're multiplying a mixed number by a whole number. This is going to be easier than the first problems we were doing. No big deal here. But remember, we have to write the whole number as a fraction. So any whole number can just be written as over 1. That'll help us multiply the whole number into what will become an improper fraction. So just write the whole number as 9 over 1 and then rewrite 3 1/3 as an improper fraction as usual. And then you can just multiply straight across. 9 times 10 and 1 times 3 is 3. You could put 1 times 3, but the 1 is not really necessary. So now you factor 9 to be 3 times 3. And 3's cancel out, and you're left with 3 times 3, which is 30. And on the bottom, you're left with 1. But 30 over 1 is the same thing as 30. So let's do one more of these, and then you can do number 16 on your own. So 4 becomes 4 over 1. 2 1/2 becomes 5 over 2. Go ahead and keep them in factored form. Multiply straight across, right? Multiplying straight across. 1 times 2. And you can factor 4 to 2 times 2. And I'm just keeping the 1, I guess. I don't know why. Cancel out the 2's, and you're left with 10 over 1, which is 10. All right. So that's pretty easy. Why don't you try 16, and when you come back, we'll do it together. All right, we're back. Convert the mixed number to an improper fraction. Convert the whole number to a fraction. Then, as usual, multiply straight across. We've got 2 fractions, so whenever you multiply fractions, just multiply straight across. You get 15 times 3 over 7 times 1. I'm not going to write 7 times 1, I'm just going to write 7. 7 times 1 is 7. You know that from class 6 or 7, whatever that was. So actually at this point, I just realized we don't have any common factors, so we're just going to have to multiply 15 times 3. That's not one of our multiplication facts, but again, you can set it up and just do the multiplication like we learned in class 6, 7, whatever that was. Multiplying multi-digit whole numbers. 3 times 15 is just 45. Now, how do I know that? Well, experience. You may not know that if you haven't done multiplied numbers as much as I have, but I just know that 15 times 3 is 45 by memory, even though that's not one of our multiplication facts. So now we have a improper fraction. We can't leave it as an improper fraction because, again, 45 sevenths is hard to understand. So we have to convert it to a mixed number. How many times is 7 going to 45? 7 times 8 is 56. That's too much. 7 times 7 is 49. Too much. 7 times 6 is 42. That's going to be it. It goes in 6 times. 7 times 6 is 42. 45 minus 42 is 3. And rewrite the denominator. 6 3/7. All right. And why don't you try number 17, and when you come back, we'll do it together. All right, we're back. 8 becomes 8 over 1. The mixed number becomes 21 over 4. Multiply straight across. 8 becomes 2 times 4, because I know my multiplication facts. 4's cancel out. 2 times 21, you can set it up if you want to, but that's pretty easy to do in your head, is 42 over 1. There's nothing here, so it just equals 1. 42 over 1 is the same thing as 40. So if you got that one right, pat yourself on the back. Good job. If you didn't get it right, don't worry. We're going to do a lot more of these problems. Try number 18, and when you come back, we'll do it together. All right, we're back. 4 2/3 becomes 14 thirds. 3 becomes 3 over 1. And we're going to keep it in factored form, multiply straight across. And 3's obviously cancel out, and you're left with 14. All right, so that's multiplication of mixed numbers. We multiplied a mixed number by a mixed number, we multiplied a mixed number by a fraction, and we multiplied a whole number by a mixed number. And it was all kind of just the same procedure. Change whatever you're starting with to fractions, and then multiply straight across. And then if you get an improper fraction, as we did in this case, convert to a mixed number. That's all we're doing in this entire class. At least the first half of this class. We're done with the first half. Now we're on to the second half. Now we're going to be dividing mixed numbers. They're probably thinking, wow, division, this is going to be hard. Well, actually, it's not that hard at all. It's almost the exact same thing as multiplication. That's what you're going to find. So we already know how to we already know how to divide fractions. For example, 2/9 divided by 3/4. If you recall from class number, I think it was 13, you keep the dividend, you switch the sign to multiplication, and then you flip the divisor. See how we flipped this from 3/4 to 4/3? So if you're dividing fractions, you keep the dividend, you change the division sign to multiplication, and then you flip the divisor. That's what we learned again in class 13. Or maybe it was in class 13, I'm just guessing by memory. So that's the same thing that we're going to do in this algorithm. The only difference is we're starting with mixed numbers. These are mixed numbers. So we first have to convert to improper fractions. Then once we go to improper fractions, then we just follow the same algorithm we used for regular fractions. So as you can see, this is going to be pretty easy. So let me do the first two ones for you, and then you can do the other ones yourself. So convert to improper fractions. So all I did was convert those to improper fractions. That's all I did. I didn't do anything else. I didn't divide. I didn't do anything. I just converted both those mixed numbers to improper fractions. Okay, so now we follow the same old algorithm that we used in class 13 when we were dividing normal fractions. We keep the dividend, we change the sign to multiplication, and we flip the divisor. So now it just becomes a multiplication problem. We're multiplying fractions. So it's the same thing we were doing all for the last 30 minutes or 20 minutes, however long it's been. 7 times 4 is 7.4, obviously. And 4 times 9 is just 4.9. And I don't know if I mentioned, but you remember these dots here. Hopefully you remember that those dots are just a different way of writing multiplication. And why do we write dots instead of crosses? Well, because it's just easier to write them, because we have to write so many of them at this point. It's easier to use dots instead of crosses. Now, is it confusing to use dots and crosses? Yes, it is. But that's just the way the math curriculum has evolved. So now we've got 4s, cancel out the 4s, and you're left with 7/9. All right, number 20, convert to improper fractions. So all I did was convert to improper fractions. All right, so now we just use the same old division algorithm. Keep the dividend, change the sign, the division sign to multiplication, and flip the divisor. All right, so now we're going to put these together. So 33 times 4 over 4 times 11. And then we can factor 33 to 3 times 11. Now, how did I know that? Because I know my multiplication facts. Then we can cancel out the 11s, cancel out the 4s, and you're just left with 3 over 1, which is equal to 3. Let me move some of this stuff over. So I can make that a little bigger. All right, so we got 3. All right, so pretty easy. All you have to do is convert these mixed numbers to improper fractions and then just use the division algorithm for fractions. So why don't you try number 21? do it yourself, and when you come back, we'll do it together. All right, we're back. So 2 1/7 becomes 15/7. 2 1/2 becomes 5/2. Keep the dividend. Change division into multiplication. Flip the divisor. Multiply straight across. 15 is the same thing as 3 times 5, because I've got no common factors here, so I have to keep factoring, or else nothing's going to cancel out. All right, so I've got 5's common, so recombine. 3 times 2 is 6, and you're left with a 7 in the denominator. So if you did that one correctly, pat yourself on the back. If you didn't, that's okay. Just see what you did wrong, and we're going to go on to another one, so you'll have plenty of practice. All right, 22. Try that one, and when you come back, we'll do it together. All right, we're back. Sheesh, these numbers seem pretty big. I guess they're not too bad. All right, so we change to improper fractions, then keep the dividend. Change the sign, flip the divisor, blah, blah, blah. I don't have to keep saying the same thing over again. 77 times 4 over 8 times 11. All right, so 77 is 7 times 11 because I know my multiplication facts, and 8 is 2 times 4 because I know my multiplication facts. So cancel out the 4's, cancel out the 11's, and you end up with 7 over 2. Now at this point, you're probably thinking, well, we're done, right? Well, you're not done, because you can't leave the final answer as an improper fraction. No teacher wants to see a final answer as an improper fraction. Well, maybe some do, but not usually. All right, so we have to change the improper fraction to a mixed number. How many times does 2 go into 7? It goes in 3 times, because 3 times 2 is 6. 7 minus 6 is 1 is the remainder, and then just keep the denominator. So if you did that one correctly, pat yourself on the back. Let's go on to number 23. Divide 7 1/5 by 2 3/5. So make sure you do it correctly. Don't divide don't divide 7 1/5. Wait, I keep saying it the wrong way and writing it the correct way. Don't divide 2 3/5 by 7 1/5. That will not give you the right answer. You got to write this number first. Now the order of the wording is not always the same as the order of the actual operation, but in this case it actually is. Write this 7 1/5 first, and then divided by 2 3/5. Try this problem, and when you come back, we'll do it together. All right, so we're back. 7 1/5 divided by 2 3/5. Oh, whoops. Fives cancel out. I'm running out of room here, so I'm going to make this smaller. And we end up with 36 over 13, which is an improper fraction. Now these numbers are kind of big. We have to see how many times does 13 go into 36. It goes in, let's see, 2 times 13 is 26, 3 times 13 is 39. That's too much. So it's going to go in 2 times, which is 26. 13 times 2 is 26. Then 36 minus 26 is 10. And just keep the denominator. 2 and 10/13. Try number 24, and when you come back, we'll do it together. All right, we're back. 1 1/3 becomes 4/3. 5 8/9 becomes 53 over 9. And by the way, this is not a race. Okay, I'm going fast because I'm trying not to bore you by just going too slow. But this is not a race. You don't have to go as fast as I'm going. Do you understand that? In fact, you probably shouldn't be going as fast as I'm going because you need to slow down and make sure you understand this stuff. I've been doing this stuff for decades. So it's okay for me to go fast, but you need to make sure that you understand this stuff and slow down. All right, so 4/3, 45 plus 8 is 53, just checking my work. So now all we did was convert to mixed numbers, and we use the division algorithm for fractions. All right, and then we have 4 times 9 over 3 times 53. Factor the 9 to 3 times 3. And there's 1 3 in the bottom, and that means we can cancel out only 1 3 in the top. We can cancel out either one, but not both. Then we recombine the 4 and the 3. 4 times 3 is 12, and you're just left with 53 in the denominator. Why don't you try 25, and when you come back, we'll do it together. All right, we're back. 9 1/5 becomes 46 over 5. 17 over 10. (46 times 10 over 5 times 17). 46 times 10 becomes 2 times 5. Cancel out the 5s. 46 times 2 is 92. That's kind of a big number. Over 17. Over 17. Then we have 92 over 17. How many times is 17? Let's make this smaller. Move this stuff over. Sorry, I should be writing smaller. All right. So 17, how many times does 17 go into 92? Let's see, 17 times 5 is 85. So that should be it. 5 times. 17 times 5 is 85, and 7 over 17. 92 minus 85 is 7. And then just rewrite the denominator. So you should have gotten 5 and 7/17. Now, if you're wondering how I multiplied 17 times 5 so quickly, well, that'll just come over time. As you learn this stuff, you're probably going to be, even faster than me when you start to get this stuff going. When you get the experience and practice. So I'm going to double check that because I did that pretty quickly. So just bear with me here. That'd be 2, 80, 92, 5. Yeah, it seems right. All right, now do 26. When you come back, we'll do it together. All right, we're back. Wow. There's no common factors. This one was kind of a hard one, but I think 2 times 19 is actually 38. Yeah, it is 38. I'm sorry I gave you another hard one. Let's just multiply straight across. So 38 times 12. Again, I don't mean to give you these hard ones, but it's probably good for you to practice your multiplying 2-digit numbers. Not that you really have to multiply 2-digit numbers. You can just use this method I'm using here. So 38 is 2 times 19. So I changed 38 to 2 times 19. 20, 18. Cancel out the 19s, and you recombine the 2 and the 12. The 2 times 12 is 24. That's not one of our multiplication facts, but still, we can do it. And by the way, just because something is not one of our multiplication facts doesn't mean that you can't do it. Because remember, you learned how to multiply two 3-digit whole numbers. So if you can multiply two 3-digit whole numbers, you can definitely multiply 2 times 12. All right, now if you leave it as 24 over 5, you get a point taken off, so we have to convert it to mixed number. 5 goes in 4 times. 5 times 4 is 20. 24 minus 20 is 4. And keep the denominator. Keep your denominator here. All right. Let me just double check my work there. Yep, that looks right. Okay, so now we're going to something a little different. In the previous problems, we were multiplying mixed numbers by we're dividing mixed numbers by mixed numbers, right? Mixed numbers by mixed numbers, mixed numbers by mixed numbers. But now we're dividing a mixed number by a whole number. But there's nothing really different. All you have to do is just write 7 over 1, and then just treat it like a fraction. So we're going to go ahead and convert. I'm going to do 2 steps at once. We're going to convert 3 5/9 to 33 over 9. Wait, that should be 32. I'm sorry. 32 over 9. And then we're going to change 7 to 7 over 1. So all I did was convert. You know what? I'm going to take that step by step. I don't want to confuse you by doing too many steps at once. So 3 5/9 divided by 7. So I'm writing the exact same thing, except, I'm sorry, I should write more legibly. All right, 3 5/9 divided by 7. So I just wrote the same exact thing, right? The only difference is I'm going to write 7 over 1. So now the whole number is now like a fraction. So we can just use the same algorithm that we've been using before. So we're going to just, as usual, we got to convert this to a fraction. So that becomes 32 over 9. And now we're just back to the same old thing. Okay, the dividend stays the same. You change the sign to multiplication, flip the divisor. 32 times 1 is 32, and 9 times 7 is 63. So we got off easy on that one because that's actually not reducible, or able to be reduced. So let's try 28. This is the same type of problem, except now the dividend is a whole number, but it doesn't change the algorithm. So we now write 6 as 6 over 1. Then we take the mixed number, and as usual, we have to change it to a fraction. Then we use the division of fractions algorithm. And then we multiply straight across as usual to get 30. 6 times 5 is 30. 1 times 17 is 17. But we can't leave it as a mixed number, right? We have to change it to an improper fraction. So in order to change it to an improper fraction, we learned in the last class that you figure out how many times does 17 go into 30. It goes 1 time. 2 times 17 would be 34. So that's too many times. So 17 goes in 1 time. And then 30 minus 17 is 13. And you just rewrite this denominator here. All right. So that's dividing a mixed number by a whole number, or a whole number by a mixed number. As you can see, it's the same type of deal. So why don't you try number 29? and when you come back, we'll do it together. Remember, just rewrite the 2 as 2 over 1, and it becomes the same division algorithm. When you come back, we'll do it together. All right, we're back. I did 2 steps at once there. You got 1 times 38 is 38. 7 times 2 is 14. How many times is 14 going to 38? I think it should go 2 times. 2 times 14 is 28. 38 minus 28 is 10. Rewrite the denominator. So if you got that far, that means you did great. You did pretty good. But there's one little thing. You'll get a point taken off if you leave it like that. We changed the improper fraction to a mixed number, so we did good. But we have a fraction inside the improper fraction that can be reduced. So rewrite the 2 and divide both sides of this fraction by 2 to get 5 over 7. Now, how did I know to divide both sides by 2? Well, first of all, they're even, so that if they're both even, that can always be divided by 2. But I know 2 times 5 is 10 and 2 times 7 is 14. So 2 goes into both, so I can divide both sides by 2. How do I know that? Multiplication facts. All right, why don't you try number 30, and when you come back, we'll do it together. All right, we're back. Rewrite is 8 over 1. And change to a improper fraction. And use the division algorithm. Multiply straight across. The fraction algorithm. And 24, if you know your multiplication facts, you know 24 is 3 times 8. So we just wrote 24 as 3 times 8. 8's cancel out, and you're left with 7 over 3, but we can't leave it as 7 over 3 because that's an improper fraction. So how many times does 3 go into 7? It goes in 2 times. 3 times 2 is 6. 7 minus 6 is 1. And just rewrite the denominator. All right, number 31. Try that one. Wait a second. Oh, this is different. So we have to do these 2 together. Now we're dividing a fraction by a mixed number. Not like it's any different, though. Maybe I'll just do the first one and you can do the rest. 2/5. All we're going to do is this is already a fraction. We just have to convert this to a improper fraction. So we just rewrite the 2/5 and then change 4 2/3 to an improper fraction. That'll be 14 over 3. Then use the division algorithm. All right, then at this point, we're just multiplying 2 fractions, so you just multiply straight across. 2 times 3, 5 times 14. And I'm going to factor 14 to 2 times 7. How do I know that? Because my multiplication facts, 2 times 7 is 14. Cross out the 2's. And I'm left with 3 over 35. How did I get the 35? Well, I just recombined the 5 and 7. I multiplied the 5 and the 7. All right, so as you can see, that it's the same thing. No big deal. It's just a slight variation of what we were doing. So why don't you try 32, and when you come back, we'll do it together. All right, we're back. Change 7 1/3 to an improper fraction. Use the division algorithm. And 22, just multiply straight across. And 22 is 2 times 11. And 4 is 2 times 2. There's two 2's. There's only one 2 in the top, so only one 2 in the bottom can cancel out. 11 times 5 is 55, and 3 times 2 is 6. All right, so again, we can't leave it like that. That's an improper fraction. Why is it an improper fraction? Because the numerator is bigger than the denominator. So how many times does 6 go into 55? Again, if you're wondering why I'm figuring out how many times 6 goes into 55, that's just because that's how you convert a mixed number to an improper fraction. That's what we learned in the last class. How many times does 6 go into 55? 6 times 8 is 48. 6 times 9 is 54. So that's the closest we can get. 6 times 9 is 54. 6 goes into 55 9 times. And then 6 times 9 is 54. 55 minus 54 is 1. Rewrite your denominator. So if you got 9 and 1 6, you did good. Good job. Try 33, and when you come back, we'll do it together. All right, we're back. Change the... I'm just going to do it. I'm not going to talk. You're probably getting tired of me talking. All right, I just realized that there's no common factors in this one. So we're just going to have to multiply straight across. 3 times 9 is 27. And remember, when you multiply any number by 10, you just take that number and add a 0. So it'll be 170. We discussed that in, I can't remember which class, 5 or 6, can't remember. 27 over 170 cannot be reduced. All right, good job. Now, if you didn't get it right, don't worry, we're going to do a lot more problems. Let's see here. How many more problems do we have? We have 1, 2, 3, 4, 5, 6, 7. We have 7 more problems. So we're doing good. We're almost done. All right, so why don't you try 34? Try 34, and when you come back, we'll do it together. All right, we're back. Wow, that's a hard one. Well, these numbers are both even, so I know I can divide them by 2. So let's try to divide 98 by 2. You can do that in your head, or you can do the long division algorithms. 2 goes into 9 4 times. 2 times 4 is 8. 9 minus 8 is 1. Bring down the 8. 2 times 9 is 18. So 49. If you divide 98 by 2, you get 49. So why did I do that? Because now, first let's multiply straight across. And I'm going to factor 98 to 2 times 49. We just got that number 49. And then 11 times 6, I'm going to factor 6 to 2 times 3. The reason I did that is because now I have a 2 and a 2. They can cancel out. All right, so now 7 times 49, sheesh, that's a big number. Let's do the bottom first. Let's do 11 times 3. We can do that. That's 33. And 7 times 49, you can set it up if you want to, but that's just going to be 343. So this is interesting. I'm sorry I gave you such big numbers there. I didn't mean to. I'm usually pretty careful about giving you numbers that are kind of, laborious. But anyway, we got to see how many times 33 goes into 343. So seeing how many times 33 goes into another number, that's just division. So you can use the long division algorithm. We're dividing 343 by 33. How many times does 33 go into 3? It doesn't go in at all. How many times does 33 go into 34? It goes in one time. That's the first step of the cycle. Second step, 33 times 1 is 33. Third step of the cycle, subtract 33 from 34, and you obviously get 1. And now you start the cycle all over again. So you bring down the 3, and does 33 go into 13? No, it does not, so you got to put a 0. So 33 goes in 10 times, and the remainder is 13. And you just rewrite the denominator. So 33 times 10 is just 330. And there's 13 left over. So that one was kind of a hard one. So the only reason that we did this here is to figure out how many times is 13, or how many times is 33 going to 343. We knew it was going to be 10 times based on that algorithm. And 33 times 10 is 330. 343 minus 330, 343 minus 330 is 13. So that was our remainder, and just rewrite the denominator. Now, how did I know that 343 minus 330 was 13? Well, that's fairly easy to do in your head. You can do it on paper if you want, but that's fairly easy to do. 3 minus 0 is 3, 4 minus 3 is 1, 3 minus 0 is nothing, so it's 13. I forgot to put the subtraction sign, but you get the point. All right, now we go to the word problems. If bananas cost $3 1/5 per pound, and you spend $2 3/4 on bananas, how many pounds did you buy? Now, we've got problems here. These problems can be very, very difficult to figure out because you're dealing with fractions. Now, if these numbers were whole numbers, then you probably wouldn't have much trouble figuring it out. In fact, you wouldn't need anybody to show you. But these numbers have fractions in them, so we have to figure out if this is a multiplication problem or is it a division problem. And if it is a division problem, first of all, if it's a multiplication problem, we can do 1/5 times 2 3/4, or we can also do 2 3/4 times 3 1/5. By the commutative rule multiplication, either way is going to get you the same answer. So for multiplication, we don't care about the order. But if it turns out to be a division problem, then we got to get the right order, because 3 1/5 divided by 2 3/4 is not the same thing as 2 3/4 divided by 3 1/5. So we have to figure out what order is correct. We have to figure out if it's a multiplication or division problem. And then if it is a division problem, we have to figure out what order. So remember, we use the factor labeled method to figure this out. This is the method that all engineers pretty much and all scientists use, and all teachers and everybody in the academic system. This is the method that they're going to use to actually figure out how to do the problem. The algorithms are so sophisticated that, or the meanings of the algorithms, it's so mind-consuming to figure out what it is that everybody just uses algorithms, but you have to set up the problem correctly. So let's do it. We're looking for how many pounds. Okay, that's the key. We're looking for how many pounds. So we want our factor label method to be pounds. So what we're going to do is take this quantity here. We have dollars per pound. That's that number. So let's write that number. That is dollars per pound. LBS is short for pounds. And let's try to multiply it. I don't know if this is going to work, but we're just trying stuff. Let's try to multiply it. We're going to multiply that by this unit. Now this was dollars per pound, right? And this was dollars. So we're going to multiply by dollars. And what you get is dollars oh, excuse me, I got to slow down here. Dollars is considered to be like a whole number, so you just put it over 1. So you multiply straight across, and you get dollars times dollars over pounds. Now, is that what we wanted? Did we want dollar per pound? No, we did not. We just want pounds. So if it's going to be the correct order or the correct operation, we should just end up with pounds, and these dollars should cancel out. So we know that multiplication is not going to be the correct operation. All right, so let's change that. Oh, I forgot to write my number here. That would be 2 3/4, right? So now let's try something different. I'm going to keep that over here just so you can use that for reference. Let's try something else. We've got 2 other options. We know it's going to be division because obviously we know this is, well, it's not an addition problem. We can tell that, and it's not a subtraction problem. We know that. So we know it's either division or multiplication. All right, so let's take the same order, but let's change it to division and see if that works. I don't know if this is going to work. If it doesn't work, we'll just try the other order, and that's got to be the correct order. Let's see. So now we got dollars per pound. We're going to change it to division, divided by dollars. And dollars is going to be over 1. Now, because we're using division, we have to use the long division, or we have to use the division algorithm, which means we keep the dividend, change the multiplication sign, and flip the dollar sign. So then we get dollars times 1 is just dollars, and then pounds times dollars is just pound dollar. And then we can cancel out the money signs, the dollar signs, and that sounds like it's good, right? But now we're left with 1 over pounds. We don't want 1 over pounds. We just want pounds. So just by a coincidence here, both our initial answers were wrong. But to be honest with you, I'm kind of glad those answers were wrong, because now you're reviewing how to do this factor label method. You can see how to tell if it's the wrong combination or the wrong operation. I'll try to make that smaller. Hopefully that's not too small. So I'm going to break these into parts so you don't get confused here about what's what. So that we tried attempt 1, Roman numeral 1, and Roman numeral 2 for attempt 2. So obviously the next one's going to be correct. So what do we do here? Well, we just divided in the wrong order. So instead of dividing 2 3/4, instead of dividing 3 1/5 by 2 3/4, we have to flip it around, and we have to do 2 3/4 divided by 3 1/5. So 2 3/4 is dollars, and then we're going to divide by 3 1/5, which is dollars per pound. All right. Maybe I should write that a little neater. All right, now this is just considered a whole number, so over 1. And then we just keep the dividend like it is. And then we change to multiplication just like the division algorithm. Get pounds on the top, dollars on the bottom. So now when you multiply, you get dollars times pounds over dollars times 1, which is just dollars. The dollars cancel out, and you're left with pounds. So we know, because we're left with pounds, that's got to be the correct operation. Now again, I know what you're thinking. You're thinking, well, that seems like too much work. Well, one of the reasons it seems like too much work is because we did the wrong, by chance, we just did the wrong first 2 algorithms, the first 2 possible options. But that, regardless of whether or not that seems like a lot of work, that's just the way that everybody does it. Now, of course, they do it a little quicker. They don't write out all this stuff, but I have to write it out for you so you can see what's going on here. So let's go ahead and do the right division. So that's this here. Let's set it up again over here. So 2 3/4. Oh, wait a second. I'm sorry. I forgot to write the final here. So dollars cancel out and you're left with pounds. That's what we want. Put a big check mark there. Or maybe I should put a colored check mark. I'll put a rainbow check mark to mean that we're happy we did it correctly. All right. So 2 3/4 divided by 3 1/5. Now, how do we do this? Well, it's the same thing we've been doing before. We just change the mixed numbers to, and again, it's not going to take this long for you. Okay, you're not going to be explaining this whole thing. You're going to go a lot faster. Change the mixed numbers to improper fractions. All right. And use the algorithm. And looks like we have some fairly big numbers here. Let's see what happens. It's not too bad. So 11 times 5 is 55. That's part of our multiplication facts. And 4 times 16, that's not part of our multiplication facts. So 4 times 16, that just happens to be 64. And we don't have any common factors there. How do I know that? Because 11 times 5 and 4 times 64, 4 times 16. 16 is just 8 times 2. And 8 is just 2 times 2. So we just have a bunch of 2's here. And we have prime numbers on the top, so there's not going to be any common factors. So our answer is 55 over 64, and that's it. Rectangle that and you're done. Oh, wait. No, we're not done. See? I almost forgot. If we write 54 over 64, then we're going to get a point taken off. Okay? We have to write what we found. What did we find? Now, a lot of students will say, well, I don't know what we found. I don't care. I just want to go on to the next problem. Well, it's not that hard to figure out what we found. What we found is what we were looking for. What are we looking for? How many pounds? So it's pounds. LBS. That's how we abbreviate pounds. Or you can just spell it out, pounds, however you want to do it. Alrighty. So if nails cost 2 3/8 per gram, how much did a person spend if he bought 1 2/5 grams? So you can try this one on your own if you want. Pause the video. Or you can just do it with me, and then you can do the next 2 or 3 problems. All right, so if nails cost 2 3/8 per gram, and by the way, I want to mention something else. Another way that you can do this, all these types of problems, these word problems, is you can say, let's just change this to an easier whole number. Let's change that to 10. $10 per gram. And let's change this number to a whole number. Let's say that that's 2 grams. And then you can ask yourself, does this problem make sense now? If nails cost $10 per gram, $10 for 1 gram, how much did a person spend if he bought 2 grams? All right. Now, if we change the numbers, let's make this 10. Let's make this 10 $5 per gram because it's a little hard with the numbers that I chose. And let's change this number to 15 grams. This will be even easier. All right. So if nails cost $5 per gram, how much did a person spend if he bought 15 grams? $5 for 1 gram. $5 for 1 gram. How many dollars for 15 grams? Well, that's just how many times does 5 go into 15? It goes 3 times. So $3. He spent $3. So why did we do that? Because you take this number, the grams, and you divide it by dollars per gram. So that's another way to do this. You could use this factor label method, but you could also just change these to whole numbers and try to figure out how the problem makes sense. But the only difficulty with that type of situation is you have to use numbers that are easy. I chose these numbers and I realized, well, those numbers aren't going to be too easy, so I had to choose these numbers instead. But you'll get used to it with some practice. All right, so I know to take grams and divide that. Whoops, I know to take grams and divide that by this number. So grams and divide it by dollars per gram. All right, so that's one way to do it. Now I know that that's going to work out because again, I use that logic. But another way to do it is another way to see that you're doing it correctly is you take dollars, you use the factor label method, dollars per gram divided by grams. A gram is just over 1, it's considered a whole number. Change the multiplication, flip. You know what? I just did that wrong. I'm sorry. I did it the opposite direction. That should be grams divided by dollars per gram. And grams is over 1. Change it to multiplication, flip the divisor. It's the same algorithm we've been using. What in the world? You know what? I think I did this problem wrong. Yep, I think I did this problem wrong. I assumed that it was going to be division. That was kind of a dumb assumption. Now listen to me very, very carefully. Okay? I wasn't thinking and I wasn't concentrating and I assumed it was going to be division. But I used the factor label method to check. Okay? And I ended up with grams times grams over dollars. That's not what we're looking for. We're looking for how much did he spend. So the grams should cancel out. Do you see how the factor label method helps me? It helps me so I don't make mistakes. Now you're probably thinking, well, that was a waste of our time. Well, no, it was not a waste of your time because you're learning how to figure out how to do the problem. You see? So neither division method worked. Division didn't work. So you know what that means? This is a multiplication problem. And how do I prove that? Well, you take dollars, which is this, and you dollars per gram, and you multiply by grams, and you get dollars times grams over grams, and the grams cancel out, and you're going to end up with dollars. That's what we're looking for. How much did he spend? So they're looking for dollars. All right. So I should have been thinking about the problem. Should have been thinking about the problem there. So, for example, nails cost, let's say nails cost $5 per gram. And let's say he bought 20 grams. So $5 for 1 gram, and he bought 20 grams. So 5 plus 5 plus 5 plus 5, 20 times. 5 times 20 is 100, so you multiply. Now, if you make a mistake like that, it's not the end of the world, all right? It's very easy to get these things wrong if you're not concentrating on what you're doing. And even if you are concentrating, again, these algorithms are very difficult, so no big deal. So we're just going to multiply 2 3/8 times 1 2/5, and it doesn't matter which order because it's multiplication. change it to improper fractions. And I don't see any common factors, so 7 times 19 is 70 plus 63 is 133, I believe. 8 times 5 is 40. And how many times does 40 go into 133? I think it goes 3 times, because 40 times 3 is 120. 133 minus 120 is 13. And just rewrite the denominator. Now at that point, we're not done, because we haven't written the units. How much did he spend? So we want dollars. So we can spell out the word dollars, or we can spell out the word dollars, or we can just move this over and put the dollar sign in front. That's how much he spent. All right, so I showed you two methods. I showed you make these whole numbers and then try to figure out the logic of the problem, which I did incorrectly. Or you can use the factor label method to see if everything cancels out and you end up with dollars, which is how much we're looking for, how much he spent. So these are very, very effective methods. All right, find the area of the rectangle below. So you should know how to find area at this point, area of a rectangle, that is. So you tell me, how do you find the area of a rectangle? Well, we've done a number of these problems. To find the area of a rectangle, you just take the width and you multiply it by the length. And we gave a geometric argument for that in the other courses. Students just memorize that. You got to memorize that. Just put it in your memory banks. Don't complain. You got to know perimeter. You got to know area. Just memorize those concepts. That's the absolute minimum that you have to know as far as geometry when it comes to kindergarten through roughly 5th grade to pass those grades in the math curriculum. So go ahead and find the area, and when you're done, we'll come back and do it together. By the way, this method this problem doesn't require the factor label method, because we know that area is just multiplication. So this is no big deal. So go ahead and multiply. When you come back, we'll do it together. All right, we're back. 2 3/7 times 4 3/8. Like always, we can't multiply mixed numbers, or we can multiply mixed numbers, but it would be very difficult. So let's change it to improper fractions. All right, we changed it to improper fractions. And now we're going to go ahead and, if we multiply straight across, those numbers are going to be pretty huge. Well, the bottom is not too bad, but the top, 17 times 35, I don't know what that's going to be. So let's just multiply straight across and leave it in factored form. Now let's factor 35 to 5 times 7. And now we obviously we have a common 7 there. So now we're going to recombine 5 times 17, and we have 5 times 17. That's a pretty big number. So you can do it on the side if you want to. 5 times 7 is 35. 5 times 1 is 5, plus 3 is 8, so that's going to be 85. And 85 over 8. So at this point, you can keep going to the right, but if we're running out of room, it's okay to go straight down. You're going to learn this in detail when you take pre-algebra. This principle of going to the right or going straight down, but you can never go to the left or up. That's just considered, that's not the way we read. You got to go to the right and down when you read. You never read to the left and up unless you're in a different country or different culture or language. So we can't leave the answer as 85 over 8. So we have to convert it to a mixed number. These are pretty big numbers, but let's just try numbers. Well, actually, you know what? We can do that. How many times does 8 go into 8? It goes 1 time. 8 times 1 is 8. 8 minus 8 is 0. bring down the 5. How many times is 8 go into 5? It goes 0 times. So you put a 0. And so we have 8 goes in 10 times with a remainder of 5. 10 times with a remainder of 5. And then you just put your denominator. But we can't just leave it like that. Because we're looking for the area of the rectangle. So it's in inches, right? Oh, I was going to put this number down here. I'm sorry. Probably confused you with that. All right, so 10 and 5/8, but we have to write inches squared. These are square inches. We're counting squares. That's area. Area is two-dimensional. It's not one-dimensional. Perimeter is one-dimensional. These should be squares, not rectangles. I'm drawing rectangles. But you get the point. We're adding up the two-dimensional area. So when you multiply these two, you get square inches. All right, so that's number 37. I have to move this image up here because it's flying around for some reason. All right, we have 3 more problems. All right. So let's get to number 38. If an animal, so you're going to try this one yourself. You can use the factor label method. You can use whatever you want. If an animal burns 5 7/8 calories for every ounce of food, that's 5 7/8 calories for every 1 ounce of food consumed. And the animal burned 2 5/7 calories, how many ounces of food were utilized? So I'm not going to show you all the wrong ways to do this. I'm not going to show you the factor label method because that takes too long, but you can try that method. You can also do the approximation. You can just change these numbers to whole numbers. Remember that? That's when I did it. I did that problem incorrectly. So we'll try that. We'll try that method. So let's change this to 10 calories per ounce. And let's change this to let's change it to maybe 20 calories. So now let's see if we can figure out if it's going to be division or multiplication. And in 36, problem 36, I believe it was, I just assumed it was going to be division. That was a bad assumption. If an animal burns, now change the numbers to 10 and 20. Okay, if an animal burns 10 calories per ounce, and the animal burned 20 calories, how many ounces of food were utilized? So if the animal burns 10 calories for every 1 ounce, 10 calories for 1 ounce of food, 10 calories for 1 ounce, and he burned 20 calories. How many ounces did he burn? All right, so hopefully you figured out the answer there. The answer is 2 ounces. That's really easy. So 10 calories for 1 ounce. How many ounces for 20 calories? Well, obviously it's just 2 ounces. Again, I'm going to say that again. 10 calories for 1 ounce. How many ounces for 20 calories? It should just be 2 ounces. But here's the big question. How did you figure that out? What operation did you use? You didn't multiply. If you multiply, you get 200. If you took 10 divided by 20, that would be 1/2. So you didn't do that. So you did this number divided by this number, which is 2. How many times does 10 go into 20? 2 times. So you took this number, which was calories, and you divided it by this number, which was calories per ounce. So that's just another way to figure out what operation to use. So we have to take this number, 2 5/7, and divide it by 5 and 7/8. The hardest part about these problems is just figuring out, do you use division, multiplication, or, if you're going to use division, what order do you use? Most students cannot figure this out. They are not able to figure this out, but you will be able to figure it out. All right, so we're going to change it to improper fractions. And I think that's correct, right? Then we're going to change to multiplication, flip. Ouch. Sheesh. I just realized those are nasty numbers, but oh well. So you can do this on the you can do this on the side. You can do it however you want to do it. There's not really much room down there. I'm just going to do it in my head. 8 times 19 is 80 plus 72 is 152. 7 times 47, there's a fast way to do that. 7 times 40 and then 7 times 7. And then add them together. It's really easy. 7 times 40 would just be 7 times 4 is 28. Add a 0 is 280. Remember you multiply 7 times 40? 7 times 40 is the same thing as 7 times 4. You just do 7 times 4 is 28. But 7 times 40, you just write 28 and then add a 0 is 280. So there's fast ways to do this. So, but again, you don't have to know the fast way to do it. So don't worry about that. You can just do it on the side if you want. 7 times 40 is 280. 7 times 7 is 49. 49 plus 280 is 329. Let me double check that. Pretty sure that's correct. The bad thing about going too fast is that you can make mistakes. All right, so I think that's about it. Yeah, well, that is it because there's no common factors. So 152 over 329. Again, I'm sorry you have these big numbers, but that's just part of arithmetic. Sometimes you have to calculate big numbers. So at this point, a lot of students will rectangle that and go on to the next problem. You cannot do that. Okay? It's a word problem. You have to say what you're counting. You'll get a point taken off if you don't write your units. These are called units. Ounces and calories are units. Inches, feet, those are all units. Grams. So what are we looking for? What we were looking for? How many? And at this point, you're saying, I don't know what we were looking for. I'm tired. I don't want to do this anymore. Well, again, it's not that hard to figure out what we found. How many ounces? All right. So we abbreviate ounces with OZ. Now we just have 2 more problems. I'm really proud of you for getting this far. There's a lot of work here. But remember, don't complain. You're only doing this class twice a week. That's it. So twice a week and the homework, and that's it for this class. So don't complain. You have to get practice anyway, so you might as well get practice with me. All right, a rabbit hops 8 5/9 miles per hour. So the rabbit hops 8 5/9 miles in 1 hour. If this rabbit hopped 2 5/6 miles without stopping, for what fraction of an hour was he hopping? All right, so you can use, if you want to do a slightly faster way, you can just pretend that this number is, let's just say 10 miles. Choose an easy whole number, 10 miles per hour. And you can take this number and just say it's 5 miles. I don't know if these numbers are going to work, but so now let's say the problem again, because again, when you're using fractions, it's very difficult to understand what's going on. So when we convert to whole numbers, it'll be much easier to understand which operation to use. So again, I didn't show you this in the multiplication of fractions problem, or multiplication of fractions class, which is I think 13 or 14, I can't remember. But this is another way to do it. So now let's restate the problem, but now let's use these easy numbers, and now we're going to see what operation to use. A rabbit hops 10 miles in 1 hour. If the rabbit hopped 5 miles, then for how many hours was he hopping? All right. So I just realized that those numbers are going to be kind of difficult. So I'm going to change the numbers a little bit. If the numbers don't make any sense, that's okay. Just change them. So I'm going to switch these numbers. I'm going to make this 10 and this 5. And now, in fact, you know what? I'm just going to make this, going to make this 20. So sometimes you have to change the numbers around a little bit. So now that we have those special numbers, now we can figure out what's really going on here. A rabbit hops 5 miles per hour. 5 miles in 1 hour. If the rabbit hops 20 miles, for how many hours was the rabbit hopping? All right. So again, let's say that again. The rabbit hops 5 miles in 1 hour. If he went 20 miles, how many hours was he hopping? Well, you're just taking 20 and dividing it by 5. How many times is 5 going to 20? So 5 miles is 1 hour, 10 miles is 2 hours, 15 miles is 3 hours, 20 miles is 4 hours. How many times is 5 going to 20? Because 5 brings with it 1 hour. So 5 miles for 1 hour, 10 miles for 2 hours, so on and so forth. So you're just taking 20, dividing it by 5. So you're taking, I shouldn't have erased all that stuff. You're taking this number, which we turned to 20, and you're dividing it by this number. So that's how you tell what to do. If we multiplied those, it wouldn't, well, obviously that wouldn't make any sense. All right. So we take 2 and 5 6 and divide it by 8 and 5 ninths. All right. Go ahead and do the operation. All right, we do have some common factors here, I can see. So now we factor 9 to 3 times 3. Let me rewrite that 17. And factor the bottom to 2 times 3. And we've got a 3 in the 1 3 in the bottom, so 1 3 in the top cancels out, and we're left with whatever 3 times 17 is. 3 times 17 is 51. And 2 times 77, that's kind of a big number, but you can do it on the side, or we'll just do it in our head. I think that's 154. So I'm tempted to rectangle that, but I can't because I haven't put the units yet. So let's move this over a little bit. So 51 over 154. And what are the units? 140, 14. I'm just rechecking my calculations there. All right, so what are the units? You're saying, well, I don't know what the units are. I'm tired. I don't care. Well, again, it's so easy. What fraction of an hour? So that's our units. Hours. 51 over 154 of an hour. That's kind of unprofessional to do that, so I'm going to make this smaller. Remember, when you're writing an academic, when you're writing your homework or doing a test, it's considered an official academic document, so be as orderly as possible. $51 over 154 of an hour. Or maybe you can say 51 over 154ths of an hour, however you want to say that. It starts to get difficult to pronounce the numbers when you're getting to these huge numbers in the denominator. All right, so one last problem. So again, you can change these numbers to whole numbers and then see if it makes sense, and keep changing the numbers until you figure out what the operation is. Or you can use the factor label method. In this case, you're going to use tons of fuel per minute, and then you're going to use minutes. try dividing in both orders, and then try multiplying and see if you get what they're asking for, which is how much fuel? Tons. So attempt that problem, and then when you're done, we'll do it together. All right, we're back. So let's see here. This is actually going to be a multiplication problem. So if you multiplied, you did it correctly. I'm going to just speed through this because we've already been doing this for quite a while. 5 2/7, that's correct. All right. Obviously, I should move this over to conserve space. All right. 8/7 times 37 over 7. And unfortunately, we don't have any factors here, so we're just going to have to do, we don't have any common factors. So 8 times 37 is 296, I believe. 7 times 7 is 49. Just double checking my math there. Pretty sure that's correct. All right, and then we're to convert to a mixed number. We're just going to have to see how many times 49 goes into 296. So 49, that's pretty easy. We can just approximate. Let's approximate 49 as 50, and then or excuse me, round off. We're going to approximate by rounding off. So let's pretend that this is 300 and this is 50. That'll be pretty easy. 50 plus 50 is 100. That's 2. Plus another 50 is 150. That's 3. Plus another 50 is 200, that's 4. 50 goes in 4 times to make 200, so you can go in another time. And so it looks like it's going to be 1, 2, 3, 4, maybe 5 times. 5 times 49 is 245. So it's probably going to be 245. 1, 2, 3, 4, 5, 6. I have a feeling that might not be enough, but let's just try that. So 5 times 49 is 245, like I said, and then 296 minus 245. I'm going to do that on paper because that's kind of a big number. Big numbers to deal with. Subtract, and you get 51. Up. Do you see this? Our remainder is actually bigger than our divisor. So you know what that means? It means I didn't go in enough times. So again, you remember that from division. If your remainder is bigger than your divisor, you didn't go in enough times. So it's actually going to be 6 times. Six times 49 is 294. 294. Wait, what am I doing here? I'm just double checking my work here. 6 times 49 is 240 plus 54 is 294. 296 minus 294 is 2, and just rewrite the denominator. So there you go. That was a hard one. These are big numbers to have to deal with. Let me just double check that work. Yep, pretty sure that's correct. So now we have to write the final units. And the final units are how much fuel. And how do we measure fuel in this problem? By tons. So it's going to be 6 and 2/49 of a ton. 6 and 2/49 tons. And that is the last problem. So just double checking that work. 240 plus 56. Yep. All right, so that's it. Now let's look at the homework. That class ended up being a lot longer than I thought it was going to be. But again, you're practicing your multiplication tables, you're practicing all kinds of stuff. This is good practice in general. All right, so here's the homework. Here's the homework. Get a screenshot of these first 2 pages. And a screenshot of this last page. Remember, your homework has to have 4 characteristics. It has to be complete, correct, neat, and in proper chronological order in your binder. And remember, if you don't do the homework, it's a 100% guarantee you're going to learn absolutely nothing in this entire course. So get that homework done, and I'll look forward to seeing you in the next class.